Hello everyone, this is Hui Nie. Welcome to our joint work from node to graph, joint reasoning on Visual-Semantic Relational Graph for zero-shot detection. Zero-shot detection aims at detecting unseen objects in a complicated scene with multiple objects. Previous ZSD leverages the information of individual objects alone, without considering inherent relationship among multiple objects, resulting in no essential difference between ZSD and zero-shot recognition. However, scene understanding of human exceeds recognizing individual objects separately, usually using contextual information. Contextual information is important for ZSD. Our motivation is to comprehensively exploit visual and semantic relational information to enhance ZSD performance. Contextual information can help from both visual and semantic aspects. For example, large objects can be used to help detect small visually similar objects. Co-occurrence can be utilized to detect the occurred objects. Our baseline is fast semantic RCNN. Since traditional detection model cannot detect unseen classes, we need to modify them to align visual and semantic information for ZSD. We replace fast RCNN classification head with a visual semantic align module. The module is a learnable FC layer to project feature from visual to semantic. We use class word embedding as a semantic representation without external vocabulary embedding. For background, we use a learned word embedding. Our method is the graph align network, which mainly contains the following steps. First, we formulate a visual relational graph and a semantic relational graph, where the nodes are the objects in the image and the semantic representations of classes respectively, and the edges are the relevance between nodes in each graph. Second, to character mutual effective between two modalities, the two graphs are further merged into a heterogeneous visual semantic relational graph. Third, message passing among nodes is enforced to refine their representations. In message passing, each node in the graph generates outgoing message, receives and aggregates other node message. Then for each node, we use GRU to fuse the aggregating messages and the current node state. As we know, contextual information is important for traditional object detection. We further show that it is even more important for ZSD. The key idea is that contextual information can be used to eliminate unreasonable predictions. We define a metric to measure it. The results show that contextual information plays a more important role in ZSD than in traditional object detection. Compare our method with the previous ZSD methods. The results show the effectiveness of using contextual information. The qualitative results show that our method detects well in complex scenes with multiple objects. In conclusion, we verified that contextual information plays a more important role in ZSD than in traditional object detection, and we propose a graph-aligned network to use contextual information for ZSD. Comprehensive experiments demonstrate the validity of using contextual information. Thank you for listening. More details can be seen in our paper.